Hey guys, and welcome back. Today we're going to be talking about how to solve this maximum product of a splitted binary tree. Given the root of a binary tree, split the binary tree into two subtrees by removing one edge such that the product of the sum of the subtree is maximized. Return the maximum product of the sum of the two subtree. Since the answer may be too long, return it in a modulo 10 power 9 plus 7. Note that you need to maximize the answer before taking the mod and not after taking the mod. Remember, you can split the binary tree only into two subtrees, and you can do it only by removing one edge. Okay? And you need to remember that the sum of the subtrees and the product of the sum of the subtrees is maximized. This is an example. I'm going to show you how this is executed. So we got a tree over here, a binary tree, and this is the edge that we're going to cut or we're going to remove. Now we're going to take the sum of this subtree and this subtree. So the subtree sum is 11 and this is 10, and we need to multiply both of these and we will get 110. Now this one is for the maximum, but what about if I remove this edge over here? If I remove this edge, this will be one subtree and this will be another subtree. Now I take this sum over here, I will get 9, and taking the sum for this one is 12. So and 108 will be the product if I take product for 9 into 12. Now let's try removing this edge. This will be one subtree and these will be one subtree. 4 is the sum of the first subtree and this is the second subtree, and the sum of this one is 17. So 4 into 17, 7 4 are 28, I guess 68. Let's remove this edge. So when we remove this edge, this is a subtree and this overall another subtree. 16 into 5, 80 is the answer, and this is not the maximum. If we remove this edge, then this will be one subtree and these are all will be the next subtree. And so 80 will be the answer, and this is also not the maximum. So the first thing that I will be using is finding the total sum of the tree. So let's take a quick example of how this approach works. So first we'll find the sum of the total sum of this tree. So for example, it is going to be 6 here. Next, we're going to find the sum of the subtree 1. So let's have a subtree. Let's say this is our first subtree, and we're going to have the sum of this one over here, which is 2. Now that we know the total sum of the subtree and one subtree's answer, it is simply easy to find the next subtree sum. We have to use the total sum and the subtree 1 sum. So this is the first subtree, this is the second subtree. So to find it out, what do we do here is we take the total and we subtract it with the first subtree sum to get the second subtree sum. So you can simply do, to find the product, we simply use the subtree's first sum and then we just simply multiply it by subtracting the total sum from the subtree 1 sum. So that's going to give us 8. And that's what this will give us 2, because 2 into 4, it's actually 8. So it's just the same problem. And so in this, we're going to be using a traversal method. If you know a binary trees problem, you must traverse the nodes in order to compute the sum, compute anything you want to do with the nodes. You need to traverse the nodes. In this problem, we'll be using a DFS approach to traverse it. And we will be using post order. What do I mean by post order? Post order is very simple idea. It just helps us to sum the left and the right subtrees. And then you can just compute the subtree sum using this traversal. That subtree sum will represent a possible cut, which is removing one of the edges. Post-order traversals first start from the left node, then they go to the right node, then they go to the node. So the approach we discussed is first we try to take the total sum of the tree. Now that we are having a post-order traversal, it's going to go from this node. Let me show you. So it's going to go from, so the traversal order is going to go from 4, then 5, then 2, then it's going to go through 6, then 3, then 1 to the root. Now when it is 4, when the subtree is 4, it just does this. It doesn't need to do anything. When it's 5, 4 into 21 minus 4, 5 into 21 minus 5. But when it comes here, it has to go like 2 plus 4 and 2 plus 5. You need to add these root left and the right as well. So how are we going to do this? Let's understand this code line by line. The first thing that we're going to find out is the total sum. So this one is the variable and it stores 0. Then we're going to find the maximum product, and this is the modulus. Now, as per the question, you remember that we need to take modulus only after we compute the answer. It's because modulus reduces the answer to below, so you might end up losing the largest value. Okay, and you need to return it in modulo 10 power 9 plus 7. And given the root, we need to split into 2 subtrees. Okay, so these are the things. Now let's talk about the first here. This is the main function, and this one has the root node. And now that we got the root node, we can go ahead and take the total sum. I'm going to have a separate function that finds the total sum of the tree, and I'm going to have a separate function to find out the maximum product. Overall, the main function is just going to return the max product modulus of mod. It's just going to do that. And we're going to have 2 functions. The first function finding out the total tree sum. And I'm going to show you how to find the tree sum. Okay, the total tree sum. And let's go and check out how to do this. We're going to see how to do this problem. So here we're passing inside a node, and this is going to be the root node that we pass inside the tree sum. So the first thing is going to be the root. inside the root, we will go ahead and find out first. We in post order traversal, if you remember, the first node that we traverse is the left child, okay, the way end. So how do we reach there? Very simple. In return, node.val is 1. The value of this is 1. Then plus we go and take node.left as again threesome. So this time your node is going to be 2. Oh, I'm so sorry. So to explain this a lot better, okay. So the first time my node.val is going to be 1. And then when I call threesome, and it's going to be 2, so I'm going to pass in the value 2. Okay. So right now the value inside here is 2. And node.val will be 2. 2 plus, now the value of node.left is 4. And the node.right is 5, but the 4 will be called. So again, I'm going to paste it. So right now the node value is 4. The node.val is 4 plus, when I go and call threesome node.left, now the node.left is actually 0. Okay? Because the node is null, they don't have any values, so they return 0. The left side has no values and the right has no value, so this one will return me 0, and this one as well will return me 0, because this node.right is also null, so this also returns 0. Now 4 plus 0 plus 0 will return me 4. So this left one is returning me 4. When I go and do node.right value, that is 5. I go and do 5. Let me do 5. And let me do 5 here. So when I go and do 5, and when I check for my node.left value, you can see over here we don't have anything. So this is null, so it returns 0. Then I go and check my left value. This also don't have any values. So actually this one will be null whenever we go and do threesome node.left. This one will be null, so it returns 0. Then we call this one. This one will be also null, so it's 0. And when they return back 5 plus 0 plus 0, they give me the value 5. So their left and right doesn't have any values, so they return 0. This also returns 0, and this will return me 5. Now that 4 plus 2 plus 5, they're gonna return 11. Alright. Now we completed the left part completely. Now it's time to traverse this one. So when I do here, it's 3. Let me do for 3. Oh, sorry. Let me do for 3. So over here, we're gonna do for 3. And when we do for 3, node.val is 3. And threesome of 3 left is going to be 6. 6 is the value. And now 6 will be called here, and it's not null, so it's gonna go ahead and call its 6. Node.val will be 6, and it's gonna go ahead and call the left value, and the left value is going to be null, so it's gonna return 0. And it's gonna go and call its right value, that is also gonna be null, it's gonna return 0. Now the 6 will be returned back, and then the threesome of node.right. Now node.right also, you don't Note that right also you don't have any values. Over here you can see that you don't have any values to the right side. So you go ahead and so once this value is null, is 0, then 6 plus 3. So 6 plus 3, this one is going to be 9. And then we go here and we return 9 over here. So this one will be 1 plus, where is this? So they don't confuse. So 1 plus, this one return 11, and this one is 9. So it's going to be 10, and the 11 is going to be 21. So the total sum of the entire tree is going to be 21. Now we know the total sum of the tree. Now we need to go and find the sum of each of the subtree, and we need to find the product, and we need to find the maximum product, and then we need to return the sum over here. Okay. After the total sum gets stored, find max prod root. This function will be called. So first what happens over here is we take the root node. So the root node is 1. And then we go to the left side of the root node, which is 2. And the left side is 2. Again, we go inside this, due to the find max prod, due to this, we again go inside and we find the left side of the root. So now the left side is 4. And again, we go inside this function again. And again, we find the node.left, which is null. And finally, it will return you 0. Okay. And once it starts returning the 0, now, now if we go back here, and this one will be 4. So when it is 4, we go and try to find out the left, and then this line. This one will come right side. So node.right is also null. This is also null. This is also null. So left and right, both of them will be 0. Now, as both of them are currently 0, we're going to find out the subsum. To find out the subsum, it is going to be really simple. I'm going to show you how to find the subsum. The subsum is going to be node.val 4 plus no left value. The left value is 0 and right is also 0 because it returned 0 when we went through this problem. So 0 plus 0. This is going to give us the subsum as 4. Now we're going to find the product. Now the product is 4 into we found the total sum. The total sum is going to be 21 minus 4. And when we do this, we get the product. The product will be 68. Okay, then we go and find the maximum product. Current maximum product, it is 68. It will update to 68. And again, it will go and traverse because we didn't still finish it. Now, how the traversal goes is actually very simple. It just goes this way. And then it goes to the 0, 0 and returning back. Now, after it return back with 68, the next node it will go is the 5th node. Okay, the node right. So after this, it will go to the 5th node. And the same way, it will go and do 0. This will be also 0 and 5 plus, and then it will find for 21 into, 5 into 21 minus 5, that one, and then this one will go to this node with this then it will go to node 2. Now when it is at node 2, it will store these values as 4 and 5 because over here the left value will be 4 and the right value will be 4, and then finding out the subsum, this one will be 2 plus, it won't be 0, it will be 4, and the right value will be 5. Now over here you can notice in our code, if you notice in our code, we would have returned the subsum every single time. Okay, every single time the function returns, it will return the subsum. This is the subsum. So whenever we do return it back here, we return the subsum. Okay, so whenever it comes back to the left, it stores the subsum, and whenever it comes back to the right, it stores the subsum. So 4 and 5 will be stored already when it comes back to 2. When it comes back to 2, 4 and 5 will be stored, and that together will add 2 plus 4 and 5. That will give us 11. Okay, and then over here we will take the remaining sum. Okay, now after finishing node 2, it will go to node 3, and when it goes to node 3, it will go to node 6. It will go to node 6. After finishing node 6, it will go to node 3. Now, after doing everything, it will go back to node 1. Okay, but node 1, when it goes back to node 1, this one will return 11, and this one will return 9. Overall, when we add, we just get the subsum as 21. Okay, now when we get it as 21, we multiply it, and 21 minus 21, because this is the sum of the first tree. Now we don't really split here, so whenever we take the root, we don't really split the subtree. So as we do not split the subtree, another subtree is completely not there, so it's actually 0. So 21 into 0, we actually get 0 as the product.